Hello everyone. In this lecture, we are going to learn about the Numpy package of Python. Yes, before directly starting me into the topic, let me say why we are using Numpy package. The reason why we are using is to handle arrays. Why the concept of array is introduced is, as you have already seen, we have worked with the computer vision and image processing, nothing but OpenCV package with Python. There the image pixel values are in the format of NumPy arrays only, right? ND array we will say actually. Yes, and one more thing why we are using is, as I told you in this complete data analysis concept, we are going to remove duplicates, we are going to handle the replicated data, and we are going to remove the outliers and all, right? So for performing those all functions, those are actually present in this numpy package. Actually we will discuss those functions during data analysis, but before directly starting the data analysis, nothing that we will actually use pandas package, but before that, you need to understand the NumPy package actually. So that's the reason I am going to start with NumPy package. Hope from the previous lectures you have already installed the Python, Jupyter Notebook, NumPy and all the required packages. So now let me open my Jupyter Notebook. Yes, and after this lecture, I will also provide this complete NumPy notes. Yes, now just open the command prompt. And here you need to type Jupyter space notebook. Yes, once it is open, now we are going to create a new notebook. Yes, let me name this as NumPy. And this one I am going to share in the description of video once the complete session is completed. Yes. Now how we import NumPy packages? Import is a command to import packages. Import numpy. Shift enter, you can shift plus enter will run the cell, or manually here you need to click. Yes, here if you get any numbers or some star, then it indicates that the cell is being run. If number is displayed, indicates the cell has been run successfully. Here import numpy we are saying, always when you use in your program, you will not say numpy dot array. Multiple times you can't type that much lengthy name, right? Actually, it is a short name, but there are still more larger packages in Python. But we will use the concept of alias name. What actually do you mean by alias name? It alias name is nothing but you can simply call as a nickname. For example, if you consider my full name is Pramadi Sri Venkatasai Balasubramaniam Sharma, but everyone when they want to call me immediately or for some purpose, they can't call me with my complete name, right? They will simply call me as Balu. Similarly, here also in the programming concept, we will be having alias names. For NumPy, if you want, even you can give your name also, not an issue. Let me say import NumPy as Balu. Yes, Balu dot array. Yes, here you can see some argument to be passed. So, yes, I'll explain anyhow. Here you can see there is no error actually. An array is created successfully. So here you can keep your name also. But generally, as per textbooks and as per any reference, they'll use NP as the alias name. Yes. Hope you understood why we are using this concept of alias name. Now coming to next step, as I told you, are going to work with arrays. NP dot array. Yes. Array is the function present in NumPy package for creating arrays. If you just pass like this, you will get error. For example, let me say I have passed 1. Here you can say array of 1, right? Let me store it in some variable A. Run the cell. Now let me display A. Here you can see array of 1. So, for example, if you want to pass another value, here you can see the data type is not correct. So, how you need to give? Can you use a nested tuple? Yes, you can use. But if you try to add one more value, let me see, let me show. Yes, here you can see it came in format of list if you observe, but I have passed tuple. That's the thing you need to observe. In np.array, we generally pass the list actually, not tuple. So, yes, this is the simple one-dimensional array. 1D array, you can say. Yes, in arrays concept, I hope every one of you know how one-dimensional array or two-dimensional array works. This is the 1D array. Then, how do you work with two-dimensional arrays? We'll work similarly. Now, let me take B. Yes, first let me work on one-dimensional arrays. Then anyhow, I'll explain you. Yes, here let me say 4, 5, 6. Now let us call A plus B. Yes, you can see that 1 plus 4, 5 plus 2, 3 plus 6. This is the addition of arrays. Now similarly, now, let me make B inside one as a tuple. Yes, now here instead of A plus B, if you store in A, we'll check whether A works or not. Yes, inside A the values have been changed. Now in B if you work, what happens also? Oh, sorry, I have printed here A. Yes, here you can see the values are different. So again we need to run the cells. The reason is that 4 plus 1 is 5. 5. 5 is actually stored where? In A it has been stored. So 5 plus again B we are doing, so it came as 9. So remember that one, while running the cells, you need to maintain an order. Now again I am running. Yes, you can see my B is affected, right? 1 plus 4 is 5. 2 plus 5 is 7. 3 plus 6 is 9. But actually what doubt you will get? We have passed the tuple, but we are trying to modify it. But generally tuples are immutable. But in case of Numpy array, automatically this part is there, right? Highlighted one. This will be converted to list actually. Here you can see, right? B is actually tuple, but it became like a list. This is what the array concept is. Inside array, you can pass either list or tuple, but what it becomes is array. That's the reason you are getting like this. This is the array format, not the tuple or list format. That's the difference you need to notice. Now, similarly, you can perform different arithmetic operations too. Let me say b into 2. Yes, so all the values will be double. If you print b, yes, because we have not stored it in b, right? That's the reason you will get the original values itself. Similarly, you can also perform division. Yes. Here b by 2 means don't divide this 10, 14, 18 because we have not stored. 5 by 2, 7 by 2, 9 by 2. Those values you got. If you want to square, yes. 5 square, 7 square, 9 square. This is how we perform different arithmetic operations. Let me also perform subtraction. Yes. This is how on one-dimensional array we perform few operations. These are just arithmetic. Now let us go still deeper. Yes. Now let us check whether, yes, what is our actual B? Let me keep it as marked down. Presence of element. We are going to see whether a particular element is present in that array or not. Now let us consider A equals to np dot array of, here you are going to pass a list. Let me say 1 comma 2 comma 3. Yes, one time I am going to print 3 in A. Yes, if you remember, these are the membership operators, in and not in. What it will be printed? The boolean value. If it is correct, it will print as true. If it is false, it will print as false. 3 in A, that is correct. So for wrong also we need to check. Yes, here you can see, right? 3 in A. It is true. So you got as true. 5 in A, false. So you got as false. For presence of element, we'll use this in and not in operators. Yes. Now let us see type. Type of Numpy array. Here type means don't think as one dimensional, two dimensional. You have observed that type function, right? For integer it will give as int and all. Similarly, now what it will give for this numpy arrays we are going to see. Numpy dot nd array. Here what do you mean by nd is n dimensional. N dimensional array. That's the meaning. Hope you understood. So now let us see dimensions. How to see the dimension of the numpy array. Yes. Now one more thing. You may get out that passing all integers. Can we store different data type or not? So now let us see. Let me consider A only. A equals to np dot array. Now let me pass three values. 1, 2.0, 3. And in next line let me print A. Yes, here you can see all are converted to decimal. Now for example, let me copy these lines. Instead of 2.0, if I'll give 2.5, here you can see, then also after 1 and after 3, you can see decimal point. Nothing but 1.0 only the meaning is, but this is how it works. Now, we will also see how to access. Is it similar to normal list or not? Let us observe. Yes, you can see along with the data type it has printed. So let me discuss this concept afterwards. One by one in order will come. Yes. The next concept is dimensions. All this we are also performing for 2D array also. You need not worry. Dimensions. Yes. For dimensions, there is a function in our NumPy actually. It is ndim. It is known as ndim actually. So here itself, let me keep it. ARR dot ndim. Here ARR is nothing but our respected array. So since our array is A dot ndim is the function I am going to use. Just a second. Yes, actually we need not keep this parenthesis. Without parenthesis, it works. Yes. Since ours is a one-dimensional array, we got it as one-dimensional. Similarly, we are going to have shape and size also. Dimensions. Yes. Shape. Similarly, a dot shape. Here you can see only 3 after comma is indicated, right? Actually, here it is showing the columns actually. So, for example, if you consider 2D array, yeah, we will discuss while discussing the concept of 2D array. For shape, we are we are going to use dot shape. ARR dot shape. Don't keep parenthesis, guys. If you keep parenthesis, you can see it is a type error. So we should not use parenthesis. Dimensions is done, shape is done. Next concept is regarding size. Size is nothing but simply rows into columns value, nothing but the number of elements. Let me mention the heading. Here you can't observe that much difference. While we are discussing 2D array, then you can understand easily. ARR dot size. Just a second, let me give space. Yes. A dot size. Yes. Totally only 3 values are existing. That's the meaning. Now similarly we can also come across data type. Yes. Here while discussing I have just shown you two things. Where is it? Yes. Here I have shown you only integer and float. If we are using one float completely it is becoming as float. What happens? For example, here if I consider a complex number, let me say 3 plus, normally it will be in a plus ib, right? Here it will be in our Python language a plus jb. So let me say it as a plus 7j. Yes, you can see that all are converted to float complex numbers. But actually, if you print the type of a, let me show here itself. If you will print type of a, here you can see numpy.ndr. Sorry, you need to access any one of the elements, guys. Let me say a of 1 I am going to access. Yes, here you can see it is completely becoming the complex number. That's the thing you need to remember. So let me keep here everything. Even print type of a also let me include here. You can observe the differences easily. A is nothing but numpy array, nothing but n-dimensional array, and all are converted to complex numbers. Now what happens here? For suppose I am going to pass a string. Does it accept or not? For example, I am passing a. Let us assume. You can see that all are converted to strings, guys. So while working with this complete thing, you need to be so much careful. You can see if I am trying to access this 2.5 also, it is showing the type of that 2.5 also became to string. So if the order which the numpy array elements all types are changed is first prior to string, second prior to complex number, third prior to floating values, and the fourth prior is given to integer values. This thing you should remember, never forget it. Yes. Still a dot size. Now if again you will run, it will become 4. A dot shape will be also 4. Dimension is 1 only. Yes. Size is over and yes. Now if you want to see the data type, here you are accessing the element and you are printing its type, right? Without accessing, how can you know? There is a function again, a dot d type you can enter. Yes, here you can see, right? Less than U64 something in string format it has printed. Since we have used the multiple values, it is somewhat being confused. So now instead of A, let me keep it as B. Yes, you can see since B contains all integers, you got as int 64. In A, since we have used all the mix, we got something else. So generally, while working in real time, we will mostly focus only on floating or integer values. But here to show, make you understand easily, I have considered these different kind of things and all. Don't get tensed by seeing these new data types and all. Yes, let me keep it as 3 hashes D type. Here D type is nothing but a data type. ARR dot D type. Don't keep parentheses for any of the things. Yes. Hope you understood this concept, right? Here let me add one more cell and let me name it as priority, because since I am keeping it in the description of video, few members will watch only notes and they get confused. So priority for all elements data type. Yes, that's the heading. So if a character or string exists, all elements type will be string only. Let me copy this line one by one. We'll see. If a character or string does not exist and a complex number exists, all elements type will be complex only. Now similarly we are going to enter for all. The reason again and again I am telling, don't get confused, but we are going to work with a maximum integer and floating values only. If you are building some any real-time application, then you will use the strings, but complex numbers generally we don't use. If a character or string and complex number does not exist and a float or decimal, in general terms we say, right, exist, all elements type will be float only. Otherwise it will be int type. Yes, here priority concept is over and all these basic things we have covered. So now let us go to the next thing. Yes guys, now we are going to see the maximum, minimum and sum of the elements in this array. So let me keep it as marked down. Max comma min comma sum. Let me take A again. 1 comma 2 comma 3 comma 4. Sorry, np dot array, right? I am not giving as list. Numpy array. How you will print A dot max if you say. Yes, you can see it has given 4. Along with the data type, it has printed. Now, if you'll say just to print, yes. If you are using print statement, it is going to print only the value. Otherwise, it is going to print along with the data type. Here you can see if, just without the parenthesis I have entered, you can see it is giving in terms of some object. The reason, well, by seeing itself, you can understand it is related to the OOPS concept. So we are going to use here parenthesis. Similarly, we are going to print minimum and sum. Wait, here comma I did not get. Yes, run the cell. 4 is maximum, 1 is minimum, sum of all the elements is 10. Right? 7, 3, 10. Yes. This is how max, min and sum we are going to print. Yes, guys, this is completely related to one-dimensional arrays. So above this, let me name one cell, keep it as markdown, 1D arrays. Yes, this complete concept is related to one-dimensional array. Still you can work, but I want to show it with the two-dimensional arrays actually. So from here onwards, we are going to work with two-dimensional arrays. Yes. Now, how to create a two-dimensional array? For, for a single dimensional array, what you have done? Just you have passed the values, right? 1, comma 2, comma 3. This is for one dimensional. For two dimensional also similarly you can do. But here one thing you need to remember is, here also you need to keep equal number of values. What happens if you won't keep equal number of values? First let me show you the error. Here itself you can see, right? Field elements must be 2 or 3. It means that either you remove one element from here or add one more element to this tuple. That's the meaning. It is similar to our matrices and arrays concept, guys. Remember that one. Yes. Now again we got error. The reason is here we need to keep one more bracket. Yes. Now let me remove one element and show you again so that you can understand that error. Yes, same error. Either you need to remove this one element from this first list or add one more element in this second list. The reason why again parenthesis is used is because we are using two lists here. Actually, only one value to be passed. Like this, you can pass multiple nested things. Nothing but here itself, you can also add one more. But within the parenthesis, you need to mention again. That's why here NumPy arrays type is given as n dimensional. So this is a two-dimensional concept. So now let us print A. Yes. Now one by one we will also see all the things, size and all. First let us see D type. Yes. Type of A. NumPy.nd array, right? So now one by one we will see. A dot size. Size is 6. Since total there are 6 elements. A dot shape. Wait, just remove this parenthesis. Yes. 2 rows, 3 columns. But there if you observe while working with 1D arrays, when we have used the similar function shape, where is it? Just a second. Yes. Here itself you can see, right? Actually there are in terms of a single row 4 columns. But by seeing this what you will understand the first value is rows. No. In terms of one dimensional, this indicates the number of rows. Sorry, number of columns. But in general, if you use it multi-dimensional, it will indicate rows for two-dimensional. Two rows, three columns. So total 2 into 3, nothing but 6 is the size. Now similarly, we are also going to see the dimension. Dimension is going to be 2D. Sorry, A dot n dim. Yes. You can see it is two-dimensional, that's why 2 is printed. Now similarly, what are the functions we have done? Dimensions, we have seen shape, we have seen size, we have seen. Yes, D type we are going to see. Yes, here I kept as type. Let me change it. D type. Here we will get as int. Since all are the integer values. Oh. By making a habit, even I am using the parenthesis, but don't use the parenthesis, guys. Yes, this is the integer. Now, still any extra things? Yes. Arithmetic operations and all, now we will see. Let me keep it as arithmetic operations. Arithmetic operations. Yes. Now, one by one, we will see. A is already taken. Now, similarly, we will also consider B. To avoid confusion, again, I am keeping down also. Same thing I will keep. Now, similarly, B we will consider np dot array of. Here, let us consider 2, comma 3, comma 5, comma, here 4, comma 6, comma 7. Yes, now one more thing, let me consider in a different size of 2D array. 2D array means don't think 2 by 2 matrix, guys. 2D means two dimensional, nothing but rows and columns will be. So here I am going to use 1, comma 2, comma 3, comma 4. Yes. Now let me print all of them in a single line, A, comma B, comma C. Yes, 1, 2, 3, 4, 5, 6 belongs to one. 2, 3, 5, 4, 6, 7 belongs to the other. 1, 2, 3, 4 belongs to the other. Wait, it is somewhat confusion for you to see. So let me print in individual lines. Yes. Now we are going to perform arithmetic operations. A plus B if you do. You can see clearly 1 plus 2, 2 plus 3, 3 plus 5, 4 plus 4, 6 plus 5, 6 plus 7. It is similar to 1D array sum. But what if we do for different things? Nothing but for A plus C if you do, you will get this error because the dimensions are not matching. So I'll keep these errors also as this so that you can learn from them actually. So now similarly addition and subtraction also the same case. A minus B, A minus C, same errors. Now coming to multiplication, A into B if you do. Yes, that is normal multiplication. But if you, what if you will do A into C? Yes, same error you are getting. If you will do C into A, C into A. Yes, even that is also an error case. Similarly, you can perform division and all also, but we are not going to focus much here because still we need to see many concepts. Yes. Now coming to the next concept, with this arithmetic operations are over. If you want, you can also check by floor division or some power and all. So let me show here itself. For C we will do C cube I will make. Yes. Similarly floor division. Yes. Floor division also done. All the arithmetic operations have been implemented. Yes, one thing is left, reminder. Uh, Let me do with respect to mod 5. Yes. All the arithmetic operations on 2D arrays have been performed. So now let us go to the next concept. Yes, now we are going to see the concept of max, min and sum here. But there are still lot of functions which we are going to perform on these 2D arrays. Yes, don't see the time because it may take to 2 hours or more also, but you need to focus much. Now we are going to see max, min, and one more thing is sum. Yes. Then since it is one dimensional, there we have not much focused. So coming to here, yes. Now again let me consider a numpy array. New array we are considering. Here give random values, but it should be of same size. And now I am going to consider a 3 by 3 matrix. Yes, this is the 3 by 3 matrix. So now I am just going to print it. Yes. Now how to get maximum and minimum? Normally you will do, right? Let me do in a single line because this is in entire array we are solving first. A dot max. Yes. Maximum among all elements is 67. Similarly to get minimum, A dot min. Similarly for getting sum, A dot sum. Yes, you can see by adding all those values you will get the result, right? Since minimum is 2, you got it as 2. Sum also you have received. Now we are going to perform on particular rows and particular columns. For example, if you observe, this is the first row, this is the second row, and this is the third row. Now, how to get the maximum value from a particular row? We are going to see now. Now, I want to print column wise the maximum values. To print, yes, let me write the syntax first. If you want to print maximum, the function is same actually, but inside you will add one parameter called as axis, and for that axis you will give 0. 0 is for columns actually. Max in columns. Similarly, axis equals to 1. Gives you maximum in rows. Means every row maximum value you are going to get. Now let me show you. A dot max of. What happens if I just give axis? First we will observe that one. You can see name axis is not defined. Just a second. Here if you give axis equals to 0, you can see column wise you are going to get the maximum value 32, 45, 67. Now to get in Yes. Now to get in rows wise, axis should be 1. What if you give -1? Yes. What -1 is giving you? Rows wise. Row wise maximum value. If you keep +1 also, it is going to give row wise maximum value. Hope you can see, right? Yes. Similarly, for minimum also you can perform. Let me keep it in a single statement. Yes, you can also similarly perform min and sum also. We'll see one by one. Let me copy this. Let me print in a single step, guys, instead of taking two cells again. E dot min of axis equals to 1. Yes, you can see minimum from columns 2, 14, 56. Minimum from rows 23 to 17. So similarly, you can also perform for sum also. Copy this. Instead of min, you are just keeping as sum. Yes. You are going to get some column wise for this one. If you want, you can also add and verify. 3 plus 2 plus 2 is 7. 3 plus 2 is 5, 57. Yes. Remember that one axis equals to 0 is for columns, axis equals to 1 is for rows. So here itself, let me also enter those because it will be like clear understanding for you, like a notes. Minimum, min in rows, and sorry, min in columns. Now min in rows. Here you need to change as min. Now similarly for sum. Sum of elements in rows. Nothing but row wise sum we are finding. Here sum of elements in columns. Nothing but column wise. That's the thing. This is the concept of maximum, minimum and sum in two-dimensional arrays. Hope you understood. Yes, but in some places I am keeping the errors as it is so that you can understand clearly. Yes, guys. Now we are going to see a concept where we are going to fill entire array with some fixed values. Fill entire array with fixed values. Again, in that there are two types. Firstly, we'll see execution. Then here itself, I will add you notes, not an issue. One one method is by making use of np.0 of. Yes, here you need to pass the values. Yes, just a second. It is syntax error. Within this tuple, we need to keep. Yes. Yes, it is not 0, actually zeros. Yes, you can see 3 by 3 with full of zeros has been printed. Now if I give 3, 4, yes, nothing but 3 rows, 4 columns. All are filled with zeros. For that, zeros is used. If you want to fill with some fixed value, then you need to use the function called np dot full. Again, here also similarly we are using here 3 comma 4. One is the tuple size And one more is the value. Let me say 5. Yes, here you can see in 3 rows and 4 columns completely 5 has been taken place. Let me give us 2005. Yes, you can see 3 rows, 4 columns with a fixed value. So these are the two techniques. What are the techniques? First one is np dot zeros is one function. The second function is np dot full. Yes, here you can use 0 also. Let us check. Yes, the reason is if you use np dot zeros here, you will get in terms of float value. Let me store it in some variable a. Let me show a here itself. Yeah, here itself I can print actually. Print a comma type of a. Yes, not type of a. Some element let me consider. A of 1 let me say. Yes, since it is two-dimensional, to access you need to use like a nested thing, right? So, yes, here you can see it is a float type. Yes, actually accessing elements for the first one, I did not explain, I guess. Yes, for 1D array and 2D array accessing anyhow I discussed, but in these notes I have not included. Anyhow, by the end of the class we will include, it's not an issue. But here the type will be integer. So let me show you b print of b comma type of b of 2. Wait, this 2 inside I need to give. Yes, you can see here the 0 is indicating the integer type and here it is indicating the float type. Here you can give any value, it's not an issue. I am giving 2005. Yes. This is for filling entire array with some fixed values. Yes. Now, firstly, let me include the accessing of elements. So, yes. Let me include about this dimensions one. And let me keep it as markdown. Yes, accessing is similar to indexing concept. Accessing elements. Yes. Now here down one more cell I need to add. Yes, simply you will access guys. Let me say I think in bottom A is already in used. Yes, A is already in use, so we will get differently. So again let me run this cell. Yes. So that here just a second, presence of element, not that concept. Yes, accessing. Here you can see. So let me say here only again I will take array np dot array of 1 comma 2 comma 3. Print of a of 0, nothing but 1 will be printed. This is the simple accessing in one dimensional. So how do you access in two dimensional? So let me add it above this arithmetic operations itself. I need two cells. One for markdown actually. Accessing elements. How do you access is? ARR is our array name. Firstly, you will pass the rows, followed by you are going to pass the columns. So now, similarly, yes, let us consider A equals to np dot array of 1 comma 2 comma 3 comma 4. Just a second, I did not close it. Yes. Now, if I'll print, let me say A of 0 and type of A of 0, you are going to get this again the ND array. The reason why means it is something like a nested array if you observe. So now again I am trying to access now a single element. How to access to? It is in 0th location and again in that first location. Comma, similarly type also we are going to display. Type of A of 0 of 1. Yes, you can see this is how we access the elements. Now coming to the next concept, what we are going to discuss is transpose of an array. Mark down transpose. Yes. How actually we transpose is, let me consider again a matrix A. Yes, simply I'll copy because always we can't enter, right? Let me take the simple one, 1 to 6. Yes. Now, if you, yes, I'll print A once and transpose is printed using the array with dot T function, capital T. You can see, right? It became transpose. Row became completely, rows will become as columns. Yes, this is how we transpose an array. And yes, these are the things we discussed. Still there are more things to discuss, not even half completed. Let us continue. Yes, since we are dealing with these two-dimensional arrays, here if you observe, I have discussed the arithmetic operations. Here when we perform the multiplication for A and B, it is just like direct multiplication. Yes, now let me show you. But whereas in matrix multiplications, if you know, then it will be like different, right? Like R1, C1, R1, C2 and all the things will be coming, right? So similarly, yes, here my checkpoint was 59 minutes ago. So let me save this actually. Yes, this thing you need to do because if suddenly there is any power fluctuation or anything, it will does not save, entire data will be flying off. So see the checkpoint is within 3 or 4 minutes. Yes. Now what's the concept I was discussing? Yes. Simple multiplication, nothing but array multiplication versus matrix multiplication. Yes, guys. Now coming back to here again we need to consider two arrays. I know that most of you are getting headache by continuously typing all this. Actually, the reason why again and again I am entering is I want to provide this one as a notes to you guys. But if you run once, you can use multiple times. That's the advantage of either Jupyter Notebook or Google Colab. So here, let me take it as a 3 by 3 size so that it will be very much interesting. 7 comma 8 comma 9. Now similarly b equals to, in simple terms I am taking guys, because most time is being wasted, because still there are many important functions like sort functions and all which I need to discuss. Now in reverse order I will type 987 654 3 2 1. Yes. Now simply I am performing math. Sorry. Firstly, let me say it as array multiplication. What is my array multiplication? Simply A into B. If I want to perform actually our original matrix multiplication, there is a function in this Numpy package, dot function will say. A dot of B. Yes, the first thing if you observe, they simply we perform the multiplication. 1 9s are 9, 2 8s are 16, 3 7s are 21, 6 4s are 24, 5 5s 25, 6 4s 24, 7 3s 21, 8 2 16, 9 1s 9. But here if you observe, actually perform the matrix multiplication. Nothing but R1 C1, R1 C2, R1 C3. Yes, how 30 came? Let us see. General matrix multiplication, guys. 1 9s are 9. 9 plus 2 8 16. 16 plus 9 are 25. Yes, here you may get doubts, so that clearly you need to perform. This dot is going to work differently. Sorry, I have done here R1 with R1, right? Sorry. R1 and C1. This is the row and column means 963. 1 9s are 9. 9 plus 2 6 are 12. 12 plus 9 is 21. 21 plus 3 3s are 9. 21 plus 9 is 30. Nothing but this R1 with all the first elements. R1 C1, R1 C2, R1 C3. Again this R2 C1, R2 C2, R2 C3, R3 C1, R3 C2, R3 C3. That's the multiplication. Actually matrix multiplication we call. That's the difference between the array multiplication and matrix multiplication. This, yes, matrix multiplication does not belongs to the arithmetic operation, whereas this array multiplication belongs to arithmetic operation. That's the difference. Yes, now we are going to see one important topic. Let me highlight it. Sorting. Yes, it is present in NumPy actually. So let us consider the same array A. Let me copy it. Yes, and let me print it also. Print of A. If you, yes, np dot sort is a function. Let me highlight here only. Np dot sort of arr comma axis equals to, yes, some value you need to give, 0 or 1 or none. Just a second, yes, 0 came. Let me keep it as or, otherwise you will give all the three values. Just if you perform np dot sort, yes, minimum one argument is needed. So let us just pass our original array. Sorry, it is actually in the sorted order only, right? So let me give some random values. Give any random values you want. Yes, now I have done. Now, just if I am sorting, it is giving me all the values in the sorted order. But how it is giving here, you can see only within the row it has been performed. 1, 13, 62, 26, 58, 74, and all right. So, is it possible to get in reverse order? Let us check. No, reverse is not accepted. Then reversed? Yes, reverse is also not accepted. So just remove it. Yes, this is giving you completely in reverse order, but it is giving in which format? Same numpy array format only. Now, yes. Here we are going to pass different values, guys. A comma. Now I am going to pass axis. If axis is none, you are going to get as one dimensional array. Here what you are getting, if you are just performing sort, you are getting same dimensional, but row wise it is going to sort. But if you are passing axis as none, nothing but there is no axis. Nothing but there is no two dimensional. So it will become as one dimensional completely sorted one. So now one by one we will check. Sort of axis equals to 0 works for what? Columns, right? Yeah, first I need to pass array, then axis. Yes, you can see columns wise it has been sorted. 58, 62, 82, 13, 26, 99. Yes, only the middle one is different, so you can see it is sorted according to columns. This one. Now, similarly for rows, if you want, just copy it and axis you will give us 1. So it will sort according to rows. You can see 1, 13, 62, 26, 58, 74, 79, 82, 99. Yes, this is the sorting thing. And still there are more concepts in sorting. Yes, guys, these are the some of the techniques for sorting. But generally we will use np.sort is the only function. These all are actually not required, just for showing you. I am showing this. Anyhow, I will provide this complete notes link also. But in this, there are not all the things which I have discussed, because in this, the relevant things are less and unrelevant things are more. But for reading, it can be somewhat useful. And coming to the practical thing, I have mentioned more things along with the errors. So you need to prefer first preference to this one, second preference to the textbook. Now sorting concept, yes, there is one more thing. Yes, we have not seen searching in two-dimensional array, right? So now we are going to see searching in two-dimensional array. Searching. Yes. Again, you need to take the complete array. Let me take these two lines. Yes. Now let me check. Using the in operator, I am going to check whether 62 is present or not. 62 in A. Yes, 62 is present, so I got true. Just you can use the membership operators. You need not even use any other functions also. Direct with operators you can get easily. Let me say 100, which is not there, right? So it need to give us false. Yes, this is how simply you will perform searching. And one more thing, guys. Now we are going to see how to print the maximum values row indexes. How to print we are going to see. By using simple max, min and all functions. Here you have seen how to get them, right? But similarly, how can we get their indexes actually? That thing we are going to see. The thing I am not going to perform here, because it is interconnected to the previous concepts, right? So from there itself I will add extra cells. Here you can see by clicking on here, you can see here bottom continuously you can add cells. As many you require you can add. I require many cells, so I am adding. Anyhow, yes. Now we are going to see the main operations one by one. We are going to add the functions argmax, argmin and all. Actually, arg is used to get the indexes for those particular values actually. Yes. As I told, argmin, argmax are those functions. Let me just mark down argmax. Next thing is argmin. Yes. Now again here I need to consider a two-dimensional array. Yes, let me take this one itself. Run this cell. Yes, let me add two more cells. Yes. Now we are having these values. What happens if you just perform np.argmax? Yes, since I am using np here, I must and should pass my array, right? So you are getting as 2. Nothing but value you are getting. So for example, wait. Maximum. Maximum here, not this 2 actually. Remember that one. That's the mistake you are making. The maximum value is actually 66. It is present in which row? Third row. But here in programming language, we'll treat indexing begin with 0. So 0th row, first row, second row. In which row you are having maximum? Last row, right? So you are getting as 2. Now similarly, if I'll print np dot argmin of a, I am going to get as, yes. Here you can see it printed 3. Why it printed 3? It should print as 1, right? You may get that doubt. The reason is, before which I told 66, actually it is wrong. Just a second. The reason why those are printing is, here you can see the maximum value is 67. As I told, indexing starts with 0. Not, don't treat here argmax as 012 012. No, for accessing you will perform that technique. But during the indexing, 0 is for 23, 1 for 45, 2 for 67. As it is the maximum, you got 2. Similarly, at 3, you are having the low value. So, you have got the position as 3. 0, 1, 2, 3, 4, 5, 6, 7, 8. That's the indexing for argmax and argmin. If you want in particular row wise, how you will pass? Just you need to pass the terms axis. np dot argmax, nothing but indexes. You are going to get axis equals to uh, first let us print column wise. You can see it is at position 2, nothing but like this it is coming 0 1 2. This is 0, this is 0. Now again, don't confuse here that you may get as 2 or 3. Actually, based on the axis, axis means only among the 3 elements its indexing it will give. It will won't consider the entire array while you are passing the axis. Remember that one. Now similarly, np dot argmin of a comma axis equals to 0. Yes, here itself let me also do for axis 1. So that cell will be belonging to, yeah, I need to print them, right? Otherwise it will give the last one, nothing but the axis 1. Yes, you can see 200 and remaining all are 2. According to row wise, all the last elements. Yes, similarly, you need to perform for argmin. Let me copy the same thing actually. Remove this one. Instead of max, you just keep argmin. Yes, for minimum value. This is how we will print the indexes of maximum and minimum values. Either it can be throughout array or row wise and column wise. Using the functions argmax and argmin. Hope you understood. Now coming to the next topic. Yes, my checkpoint was 21 minutes ago. You need to save it actually. Yes, now it is saved. Yes, guys. So this is how in complete 1 hour we have completed the NumPy concept. Actually, it is 10 minutes and all with the introduction and all. You can avoid those timings. Yes, now one last topic with this, our NumPy in 1 hour will be completed. So the concept here comes is empty values. Let me keep as marked down. Yes, it is most important. That's why I am keeping it in a big size. Empty values. Yes, for empty values, you will be having np.nan actually. np.nan is, yes, just a second. Yes, not capital, it is small actually. NAN. Actually, why I have given capital is while working with the data analysis in the data, there we will enter in capital letters, capital N, small a, capital N. That's the reason with that habit I have entered here. Actually, in NumPy, it will be in this format. So now we are going to work. Yes, let me copy this array again. We will see. Yes. Now in you replace some values with np.nan actually, or you can store this np.nan in some variable and also you can replace. It's not an issue at all. Now in last array, let me keep in two places. Yes, you can see nan is printed, right? Nan is nothing but empty values. The reason why it is empty is in real time data when you get some all the details you will not ask from the users, right? Means you may ask his name, contact number and all, but sometimes you will ask the unnecessary details. Let us assume hobbies you will ask. Some members will feel hesitate and they will enter nothing, or some people will type it as no. So you need to handle all such cases. That's how we are going to work with machine learning algorithms and all. So for such values, you are completely going to replace with this nan actually, and then you are going to work on that data. So now we are going to count. Yes. Now here if you try to print the maximum value, let us say a dot max. Yes, just a second. Since it is two-dimensional, we need to print it differently. Yes, you need to give parenthesis. So here you can see you got it as nan. So remember that one. If you keep 0, 0 is going to be the least value. So if you try to print, it will be 99 actually. So remember nan type is by default it is float type. That's the reason all are converted to float, and here also you can see. And nan is the maximum value. You can treat it as infinity. Plus infinity in general mathematics we will say, right? Similar to that concept. You can also replace those values and all, which we are going to see while working with data analysis and machine learning and all. So now, yes. Now coming to the count. Yes, the last concept. Let me keep it as marked down. Count. We will count the non-zeros and zeros actually. So that one we are going to see. Now let me consider the array again. Yes, this array itself we will consider. Yes, this is my array, and now we are going to see the count of non-zeros. So let me take some zeros in between. Yes, guys, remove some values and keep them as zeros. Yes, np dot count underscore non-zero of a. How many non-zeros values are? Oh, sorry, I need to run this cell. No, again. How many non-zero values are there? 1, 2, 3, 4, 5. So, 5 non-zero values are there. So, is there a function for counting zeros? Let us check. Count underscore 0. Yes, there is no such function. So let us check if zeros exist. No, even that function is not possible. So you can see non-zeros. This is throughout our array. If you want only in a particular column, let us assume. Column wise and row wise also we are going to do, guys. Need not worry. np dot count underscore non-zero. My first parameter is going to be my array. And now what we are going to see is along the axis we are going to see axis equals to 0, nothing but column wise. Yes, non-zeros count, guys. This is, remember that one. Non-zero, there is only one, there are three. Now similarly, if you want for suppose row wise, what you will do, just axis equal to 1. Yes, there are two non-zeros, one non-zero, again two non-zeros. This is the working function of count. Yes, guys, with this complete NumPy basics is over, and from next lecture, in next lecture we are going to see similarly for pandas. Don't think that pandas is going to be this much easy. NumPy is covered within 1 hour 17 minutes. Pandas will take minimum 2 hours, maximum I can't say, because I want you to understand even the reason for the errors also, so that we can build a perfect application. Nothing but application means what here? While using NumPy and Pandas, you are going to perform data analysis. This data analysis you are going to use in machine learning. Again, machine learning you will link it to some app development or web development. Let us say in Python web development only. You are going to link your complete machine learning process to your Flask or Django project. So that there you need to get the good performance, which we will also learn and we will develop those kind of projects. Yes. So with this, our complete NumPy lecture within 1 hour has been successfully completed. So in the next lecture, similarly, we are going to see Pandas package. Yes, don't think that I am going to explain all these packages, because all the functions we are going to use are presently belongs to NumPy and Pandas. This scikit-learn, matplotlib, cborn, for individual applications we are going to use different formats. You need not worry. Hope you all understood. If you are facing any doubts, drop in the comment section. And in the description of video, you will be provided my this Jupyter notebook link as a PDF. And sorry, in Drive link I will upload anyhow. Yes, if you open there, you can see Python Unit 5, and one more is my Jupyter notebook. Firstly, read Jupyter notebook, then you can read Unit 5. The first Python is nothing but it is complete Python basics. Yes. Thank you.